Okay, good afternoon, everyone. Thank you for your coming to my defense presentation. The title of my presentation is Development of Robust Calibration Model for L-Ascorbic Acid Determination in Solution using Terahertz Spectroscopy. What is the motivation of using Terahertz wave in my study? Please look at this. Terahertz wave is new comparing to established regions such as mid-infrared or near-infrared region. And then Terahertz wave is located between electronics and photonics region. So it has two special characteristics. It's able to penetrate some non-polar materials such as plastic and paper with low photon energy, so it's safe for biological sensing. Our research group has motivation to bring terahertz spectroscopy into agriculture fields. So one possible application of terahertz spectroscopy is for quality evaluation of juice production. Then please look at this. An IR and mid-infrared spectroscopy has been used for quality evaluation of juice from raw material to juice product before packing. However, so far, no available licensing method that can be used for quality evaluation of juice after packing. Then, why such kind of non-destructive sensing for juice is important to be developed? In the previous study, it has been reported that there is quality degradation of juice product during storage or transportation. For example, L-ascorbic acid content in juice product decrease after a week of storage. So, for this reason, it is very important to develop non-destructive sensing for juice inside packing. However, an IR and mid-infrared wave is difficult to penetrate the packing material. So, it is not easy for quality evaluation of juice after packing. On the other hand, terahertz spectroscopy uses terahertz wave, which able to penetrate some non-polar material such as plastic with low photon energy, so it is safe for biological sensing. So one potential application of terahertz spectroscopy is for quality evaluation of juice after packing. In the previous study, an effort to develop the determination of LA in solution using terahertz spectroscopy has been conducted. For example, Suhandi et al. Has reported the acceptable measurement system for determination of LAA using terahertz spectroscopy. But this system was lacked from the information about the influence of temperature and other components like glucose. So in the present study, I developed the robust calibration model that can be used to compensate these two effects, the temperature and other components. So the overall objective of my study is to investigate the influence of temperature and glucose on the robustness of calibration model for LAA determination using terahertz spectroscopy. But in particular, in this presentation, I'm going to talk about chapter 3 of my thesis because the limitation of presentation time. So I'll focus on the calibration model with temperature compensation. For the first experiment, I used 52 samples of pure LAA solution, and then I measured the spectra of the sample at 3 different temperatures. And then I developed the robust calibration model using implicit and explicit methods. The result of implicit method will explain more detail later. In general, there are two methods for linear temperature variation. First is variable selection, and the second is global calibration. In the present study, I will develop the global calibration model with implicit and explicit method. So the objective of Chapter 3 is to develop robust calibration model for LAA determination, which can compensate the variation of sample temperature using implicit method. For this, 52 samples were used, and then I measured the spectra of sample at 3 different temperatures. This is the methods of spectral acquisition. First, I put the sample on the surface of silicon prism, and when the trace wave is come to the silicon prism, some of light will reflect it back into the sample and generate the evanescent wave. This evanescent wave will penetrate the sample with the penetration depth depending on the wavelength. And then the spectra of the sample containing the information will be detected by detector. This is the parameter used in our study. For developing the local calibration model, 35 samples were used for calibration and validation. And to evaluate the performance of the calibration model, 17 samples were used to evaluate the performance of the local calibration model. Each calibration model was used to predict 17 samples at each temperature. And then, to developing the global calibration model, we combine 2 or 3 different temperatures. For this, we use 70 or 105 samples. And then, to evaluate the performance of the global calibration model, each global calibration model was used to predict 17 samples at each temperature. And this parameter was used to predict to evaluate the performance of the calibration model. The number of PLS factor, coefficient of determination, error of cross-validation, and standard deviation ratio. And this parameter was used to evaluate the performance of the prediction, R-square, error of prediction, bias, SEP, and standard deviation ratio. Result and discussion. This is the typical spectra of LA solution in the Terahertz region, including low and high frequency with same in concentration but different in temperature. And then from here we can see that the spectral differences is larger in high frequency comparing to the low frequency. And then using satisfigulized smoothing spectra, we develop local calibration model at each temperature. And this is the result. From here we can see that all the best local calibration model at each temperature were very good quality with high coefficient of determination and low error both in calibration and validation, and high standard deviation ratio for all local calibration model. Then the performance of the local calibration model were evaluated in prediction step. First, using local calibration at 22 degrees Celsius, we can see that the total error of prediction gradually increasing with the increasing of temperature. And then the local calibration at 22 degrees show us the good prediction for the sample at same temperature. But the prediction was worse for the sample at different temperature. So from here we can see that the effect of temperature difference is larger in terms of bias, not SEP. Then using local calibration model at 31 degrees Celsius, we obtain the good prediction for the sample at same temperature, but worse prediction for the sample at different temperature. And then also the effect of temperature difference is larger in terms of bias, not SEP. And then the same result was observed for the local calibration at 40 degrees Celsius. using calibration at 40 degrees Celsius, we obtain good prediction for the sample at same temperature and worse prediction for the sample at different temperature. Also, the effect of temperature difference is larger in terms of bias, not SEP. And then this graph clearly illustrates the error of prediction in terms of bias. So, for example, using the local calibration model at 22 degrees Celsius, we obtain low bias. And then the bias gradually increasing with the increasing of temperature. So, from this, we can see that the local calibration model cannot be used to predict the LAA of solution at different temperature. And then instead of using the local calibration model, we develop the global calibration model. And for this, we combine 2 or 3 different temperatures. And this is the result. The global calibration model were quite good for all combinations with high coefficient of determination and low error for both in calibration and validation and high standard deviation ratio. And then the performance of the global calibration model was evaluated using prediction sample sets. And then this is the result. The prediction result was very good with low error of prediction and high standard deviation ratio for all combinations. So this figure clearly illustrates that using the global calibration model, we can compensate the influence of variation of temperature with low bias. So, using the global calibration model, no bias was observed anymore. And as conclusion, in this study, we investigate the effect of sample temperature on model performance of LAA determination in broad range of terahertz region at 3 different temperatures. And then the prediction result of using global calibration model is improved significantly with low bias in low error of prediction and high standard deviation ratio. And then the last one, the global calibration model can handle the influence of sample temperature on model performance. Okay, that's all my presentation today. Thank you for listening. Any suggestion or comment will highly appreciate it. Thank you.
Any suggestion for improving presentations? Anything? I forgot to give you this. Anyone?
First of all, let me compliment you on your presentation. It was very easy to follow and it told a story that was really easy to follow. One concern I had was you used the word robust quite often. In analytical chemistry, robust has a very specific meaning. And so maybe your meaning is slightly different from what analytical chemistry means when they say robust. it's maybe good for you to define what you mean by robust. Low sensitivity to sample temperature.
Yes.
Would be able to explain your model in what it's trying to achieve. Robust is maybe a little bit more abstract, more difficult to understand what you're trying to achieve.
Thank you.
Do you have any comments about the word robust? How did you use robust?
Yes. As the information I know, robust in my study defined that the calibration model I developed can compensate the any kind of disturbance like the temperature variation or other interference like the in the complex solution like glucose and so on. So with developing the robust calibration model, I hope I can compensate the variation, for example, of the temperature of the lamp, the aging, and so on.
Especially temperature.
Yes, in the chapter 3, I explained about the robust calibration model for temperature compensation.
Any other suggestion? Very good presentation. Yeah, much improved compared to the other day. But yeah, would you show us one by one? We check your this PowerPoint slides. This page is okay. Any misspelling or anything? I think we have another logo. This is white background is okay. Your background is blue, so maybe we have some transparent this logo. That would be that's very small. And yeah, please next slide. Any suggestions on this slide? Okay, next. Comments? Okay. Okay, next. Okay.
Here you say the infection after the packing is important.
Yes.
Is it really important measure the content just before and after packing? I think the content of the material is not so different before and after packing. When do you want to measure?
Yes, actually I want to focus to use the trace wave because for the quality evaluation of juice before packing, it has been conducted and established using the NIR and mid-infrared. So far as I know, no biosensing method that can be used for quality evaluation of juice after packing. So for this reason, I propose the use of Terahertz spectroscopy. For
What kind of thing do you want to use this method? Factory or somewhere?
sorry.
Where do you want to use? Do you want to apply this technique?
Actually, I want to, in the field, of course, we will difficult or it's impossible to fix or control the temperature of sample at the fixed temperature. So I want to compensate the variation of temperature, and then I think without experiment about the temperature variation of the determination of temperature variation, we cannot use the Terahertz wave in other application. So I want to purpose the developing of robust calibration model of L-Ascorbic determination with temperature compensation, so it can be used for the other solution, other complex solution with different in temperature, and then more complex solution, and then at different temperature, at different concentration, because it's impossible.
He is asking what kind of place, maybe food industrial factory or some other inspection, some special place or something like that. Maybe food industry.
Yes.
Right? Maybe you would like to ask.
So, if you use this technique in factory just after packing, I think the content of ascorbic acid is not different just after packing and just before packing.
I think from
So I think measurement after packing is necessary. It's not necessary.
I have show you that from the previous study, the quality degradation can occur during storage or transportation. For example, the Borderlus et al. Paper said that the LA content decreased after 8 weeks of storage. Even in the few time, only 8 weeks of storage, the concentration of LA in the solution decreased. So, and for application, we need maybe more long time for storage and transportation. So, and we want to develop the online biosensing, so we don't need to open the packing material so far.
Maybe back to my first question. So, in that previous study, you trace for 8 weeks, very long time. So that thing is not suitable, not correspond to application of factory.
Of course, for the application, we need more investigation, more research, more experiment about, for example, the temperature in the factory, and then the influence of the packing material and so on. I do the experiment on the laboratory with we try to control the temperature. But of course, for more larger application, we need more investigation about the other factor that can be influence the calibration of the model. But my research is the fundamental research about how we can compensate the temperature of variation, because without this we cannot use more state to other application of the Terahertz wave. So maybe we need step-by-step experiment for this. more complex application, I think. Of course, the result of my experiment cannot be directly used for the application, but we need such kind of information for the application of terahertz wave, for example, more complex solution and so on. Because in my study, I got the result that complex solution with a mixture between LA and glucose, it have the possibility to determine quantitative study of the mixture solution using PLS2. So there is one step to develop the terahertz spectroscopy for more larger application, I think. Of course, not immediately use this result for application in the factory, because need more and more research and investigation about other field. But
of course, I know we know your study is basic study, so your research is very good, I think. But maybe some audience doesn't know that, and some audience will ask you why your study is important, and which thing your method can be applied. So maybe you need to prepare the answer and candidate to use that thing. For example, if I am you, some context of juice is easy to change. For example, ascorbic acid decreases after use. So the inspection at the shop or on the way, if superfan is necessary, more suitable. So in that case, destructive inspection is very suitable and important. So NIR and NIR cannot be used. How about that?
Yes. Thank you for your suggestion.
Maybe that what Suzuki-san suggesting could be emphasized by, rather than having packing here, have supply chain. And so once the carton leaves the factory and enters the supply chain, then it is subject to much more environmental fluctuation and much more potential for damage or degradation. And the most important point at which ascorbic acid concentration is needed is when the consumer makes it. Even if you have a high ascorbic acid in the factory, if when the consumer is drinking that juice, the low ascorbic acid, then that high concentration has no meaning. So you need to also understand how ascorbic acid concentration changes during that supply chain when sometimes there is no refrigeration or high temperatures or whatever.
Thank you, Frank. Very good suggestion.
Maybe for this, you better to mention that you want to develop something that is will benefit both side, producer and customer. As mentioned by Suzuki-san, it's better after packing, direct after packing will be not so necessary, but in supply chain, as mentioned by we will need to evaluate to benefit the customer, and then so your will benefit the customer and also the producer. So the total quality management can be established. So to make sure that the customer pay for what they have to get, because the LA is usually add as the additional in soft drink.
And that is a very important part, how to convince scientists. That's maybe very important. So you prepare for the answers. Anything else?
Yulia-san, actually Terahertz waves can penetrate much more than the infrared resolution, but is it really possible to distinguish the better fresh juice and old ones in the spectrum from the Terahertz region?
Sorry, please repeat.
Can you distinguish the better juice and worse one?
Better juice.
Better juice and worse, yes. The contained juice.
Mm-hmm.
Can you distinguish them from the spectrum in the Terahertz region?
Can you?
Can you distinguish that the least one and others?
Yes. You mean using Terahertz region?
Yes. The freshness of the juice, can you difference?
Using Terahertz region, can we difference the content of juice? Yes, we can. I think we can because from the results in about the determination of the complex solution, we use PLS2 to develop the calibration model, and then the results show that we can discriminate between L-Ascorbic acid and glucose in the mixture solution, but we have to use the PLS2.
When we work the freshness, your system calculates the percentage of LA, not the freshness.
Oh, sorry, you say about freshness.
If sudah freshness, you can differentiate the LA and the fresh one, the old one. So we have to move to principal component analysis to just differentiate this old one or new one. But it's not your target. The target is to evaluate the percentage of LA, not the fresh one.
Ah, sorry. You said about the freshness. Ah, sorry. I misunderstood.
Okay, anyone else? Next. It's okay. 120 PS1,
PS1.
20, a little more space, 450. It's okay? Next. Very small thing. Start with capital.
Component space. Other components.
Components. Plural. Okay. Next. Bottom. That only that. Okay. This page.
What is chapter 6?
I meant chapter 3 of my thesis.
if you want to put maybe parenthesis at small letter, this is some big title. Chapter 3. But yeah, if you like to explain, I have observation, and but this chapter 3 is the most important in my presentation, or something like that. If you explain, maybe not bad. It's up to you.
Also, the influence of temperature. It sounds as though you're going to have a large range of temperatures and look at how the values gradually change. Whereas where you explain it, it sounds more like you are looking at the sensitivity of ascorbic acid determination to temperature variation.
This is the chapter title.
Yes.
So you may revise like that.
I'm sorry, I forgot what you said in this slide. What do you want to explain in this slide? Objective?
No. The focus on my presentation.
Focus.
What I want to explain. Because in the previous I said that I want to develop the robust calibration model that can compensate the variation of temperature and other component like glucose. But in this presentation, I only will explain about calibration model with temperature compensation and about the mixture solution in the next chapter.
So partly you did master thesis, research. Then you focus to part all of research in this slide, right? Yeah. So it is, I know. So this presentation is a part of your oral research. But in this slide, we cannot understand that. So my suggestion is to show the objective of all of the study and your small objective in this presentation, both of them.
Explain about the overall objective in the previous slide.
From this slide, we cannot understand. You focus to part of your research. Why don't you emphasize you focused?
Which page you are talking? Which page?
This is.
You told us that all objectives.
The overall.
Which page?
This is. This is for the overall objective. And then?
One of them are temperature. The other one is another component. This is chapter 3.
Chapter 3.
This is chapter
5.
5.
Chapter 4 about the PS2.
If you would like to show chapter 3, maybe you put the 3 here. they don't have your dissertation in their hands. How?
Maybe we can combine
Combine. Combine for how?
for the object.
For instance, in temperature, underneath brackets, chapter
Yes,
3,
yes,
up
yes.
brackets, chapter 4 and 5.
That maybe this one. You have to know that you have to tell them this is this one.
Yes.
And we cannot match. Yeah, Suzuki-san. Yeah, the same.
So my suggestion is to emphasize here. Here you can emphasize your objective of this presentation is only temperature, effect of temperature. So everyone can follow, I think.
Okay.
So we don't need a chapter 3. You have a chapter 3, chapter 3.
Yes.
We don't need. Yeah, you can say, I'm going to present about this robustness for temperature. And then immediately you can show this one.
Yes.
That's good. Show. Number 7. How about this page? Chapter 3, chapter 4 here. And chapter 5 also you are talking something. No, nothing. Chapter about chapter 4. No. Chapter 3. And experiment 1. 1 means
For the chapter 3.
chapter 3. Chapter 4 now experiment 2.
Actually, this is for chapter 4 too. This sign.
Chapter 3
and 4.
and 4.
Yes.
Experiment 1. Experiment 1 for these 2 chapters. And experiment 2 is chapter 5.
Yes.
We don't need 1. Actually, we don't need this block, actually. Yeah, design of experiment starts from here. Maybe we don't need it. I think in this chapter 3, the use of presented. Yeah, if you would like to show your dissertation and your dissertation outlines, maybe you may talk about that. But you are focusing on only chapter 3. Yeah, you may omit these. Of course, you explain the FTIR, ATL, Terahertz spectroscopy device and method later. So maybe you don't need that. Important thing is those robustness for 22 degrees, 31 degrees, 40 degrees. You developed that robust model. That is important in your this time presentation. Any suggestions? Maybe more make this one simple. Okay, next.
Before page number was 5, but Saturday was 8.
What?
Page number.
Page number?
8.
Please go back before, sorry.
Go back?
Hi. Maybe you change later.
Yeah.
You may omit some of them, so maybe renumber later. You have 3 temperatures, 22, 31, 40. Next page is only 2 temperatures.
Oh,
That's fine.
yes, this is only example. Only example for global
Example.
calibration.
But you have only 3. Example, 2 of them are example.
This is example for developing the global calibration.
Any suggestion? Please.
You write at the bottom, combination of calibration samples from a broad range of temperature was conducted. It is debatable whether 22 to 40 can be called broad. Better to not say, that's a value judgment. You making a value judgment. Maybe somebody else would say from 5 to 50 it's broad. But it's not necessary to write. Just a calibration, a combination of calibration samples. Also, a large data set was required.
Not. You mean we don't need to put?
No, large data set was required.
Okay. Data set.
Next.
Yes.
Yeah, maybe you can omit that. And materials.
Material.
Okay.
What is SM? What is SM?
SM.
number of samples.
How did you abbreviate into this? Maybe you don't need it. Yeah.
In your previous number 10 on the slide number, you already had 52, 52, 52 in the temperatures. Are you not repeating what was already said?
Yes, yes.
What's so effective? This one. 52 samples, LAA. So not so maybe deconstruct much.
Okay.
Anything else? Next page. Okay.
The red box on the right, all the information is also in the figure and in the thing there. You're only repeating. So maybe the white, you should say ATR or attenuated reflectance as a label for the white box.
Yes, yes.
Anyone? Next page. Prediction set.
Yes. Calibration, validation.
Validation set.
Yes.
You have a prediction calibration here.
Yes.
Maybe.
And then this calibration and this prediction.
Yeah. Your way is always double, triple. Necessary. Fine. This sentence, okay. The calibration models are presented in reason squares. Why? Square. Why? Why? What? Why? Square. Why? You don't need this. The prediction sets are the brackets. Numbers of calibration in the brackets. Addition.
said the same thing 3 times. Calibration in the box, then calibration on the right, then down the bottom. You've also again said calibration in the square. It's built-in redundancy. Also with the number 35 and 17, maybe say sample number 35. To understand that, what the 35 means.
35 data sets. Data sets. Next. Very similar sentences again.
But I want to explain about this for prediction, developing the prediction.
Yeah, I understand. Maybe you may be able to merge more efficient way to show. Any other ones? Maybe similar thing that maybe you may reconstruct with previous one. Following parameters, and if you do this number of PS factors, then parentheses smaller than because of parentheses plus there.
Or smaller is better. Change color to show that this is you're indicating which is the better one. So for the RMS ECV, the you don't need, and it should be closer. Close R.
Yeah.
Don't need and the.
And next two.
You don't need brackets SDR. Of calibration, then SDR CV. No need to 2 times.
Here.
Yes.
Here too.
so much.
Anything else? Okay, next. How many pages do you have? Maybe a little large number. That is 25?
25.
Maybe 15 or so, because 12 minutes. 12 minutes. 15 pages, at most 20 pages, I think. Okay, anyway, you may manage something. We can't follow these sentences because you have many slides. Just 20 seconds or 30 seconds, you have to quickly change the slide. During 20 seconds, we have to read this, and also we have to read this. Maybe impossible. Probably those sentences you can talk and you can explain on this graph. Maybe, yeah.
Yes, yes.
Any comment? Okay, next. Okay.
Maybe SD is more, maybe if you mention SD, SD, SD is always good. So I think it's better first you mention what is SD.
You say local calibration. When you say local, it means only at one temperature. So without temperature compensation is obvious. When you say local, it means only one temperature.
Yes.
And so with one temperature, you cannot have temperature compensation because there's only one. So no need to say without temperature compensation.
Yes. Okay, okay.
Okay.
Why don't you reconstruct the order of the slide one more time? Because here, maybe everyone cannot understand what is RMACC here. Everyone cannot remember. So, why don't you explain the mean of R square, RMACC, SDR here? You explain that parameters to before this slide.
To explain about this, because we often use these terms in the next slide, so I want to explain in the previous slide.
What's the F?
PLS factor.
What factor?
PLS factor.
PLS factor. Ah, PLS factor. You better put the F. Is time consuming. Maybe next. Next to be 40. Structure is 40. This one. Next. One before.
Maybe the dB is too far. 22 dB. The C is too far from the dB.
I have one.
This one.
Also, yeah.
Maybe. All of them.
So
I think SCP is both the other bias and SCP is different. I think you should check.
font. Okay.
Next. Okay. Next. Which one was best?
This one.
20 and 40. 22 and
Yes. So as the important thing is the range. Yes.
Okay. Some of them are. This is the italic. Should be italic. The others are non-italic. The apply. Correct? Intentionally check.
I will check. I think so.
should be consistent. If tight, so this also should be tight. I expect.
Font sometimes the change. Yes. We're going to use same font all in this presentation file. Okay, next.
Stop.
Period. This broad range. Change. The prediction results. Ah. Also using no. Probably, yeah, some grammatical errors and the font, so some consistency, start with the capital or yeah, just appearance is also important when you present in defense. So should be consistent all in this materials, in this presentation file.
The first one in this study we investigate effects is not necessary. All you need to say is model performance of LA determination at 22, 31 and 40 degrees C. It's the rest broad range terahertz region is at this stage unnecessary detail.
I think you received very many suggestions. You have still have much time. The next deadline would be abstract, extended abstract, August 5th. Then this deadline would be August 7th. 3 weeks, 2 weeks. You have 2 weeks. I think. Yeah, a few more times present in front of some research group members and more groups. Also, yeah, you may ask the Pearson the grammatical check and some right English, first English.
Yes. Thank you.
Okay. Okay, thank you very much. ありがとうございます。